Guten Morgen, guten Tag, guten Abend. We will together, myself, Mikhail, and my colleague Ting. Ting, how are you?
Good. Let's get this started.
Let's get this started. We will go through exercise 4 together. We are in the CWatM GitHub folder, tutorials. Ting's just gone to exercise 4. First thing we'll do is update the file path for the 30 arcmin global climate dataset, and then check a few other things in the settings file. So yeah, Ting, would you open up the settings file for the Beamer basin? Scroll down slightly until we get to path maps.
I can also search them.
Yeah, okay, perfect. Okay, this PathMeteo, and then you will put the path to the folder containing the global climate data. For everyone else watching this video, you'll have to download the global climate data through our FTP server. We'll talk about that in another point, or I'll put a link to that below. Ting is putting the hard path to where we have it in our server. While we're here, we can see the path route. Again, in my computer, I have all the CWatM inputs inside of a CWatM input folder. But your structure has the CWatM-30min-earth in the GitHub folder.
I want to show like
Yeah.
it is not there, but seems to be the screen is a bit too small. What is going on with my screen? So basically I don't have this part of the path that's called climate input.
Maybe you can go into your GitHub folder.
Yeah.
We see in the GitHub folder right away you have CWatM-earth-30 minutes.
So it needs this one.
And if we could scroll down again just slightly to see the start date and spin up date. Okay, the step start is the first day of the simulation, and the step end is the last day of the simulation. So this simulation will run from January 1st, 2015 to 10 days later. If we put a spin up date, that will mean the model will still start on January 1st, 2015, but it won't start generating output until the spin up date. So maybe just to show this thing, maybe you can put like the third day of 2015. So 3-1-2015.
Where? You mean in a spin up or?
Yeah, in the spin up.
In the 3rd of January.
Exactly. So the model would start on the 1st of January 2015, but wouldn't start creating output until the 3rd of January 2015, but would only run until the 10th day of January 2015 because the step end is 10. Step end can either be a number or can be a date, like the 10th of January 2015.
So will this give results for 10 time steps or 8 or 7 time steps?
I think like 8 time steps.
Yeah, from 3rd of January?
On the 3rd of January.
Okay, I see. Anything else to...
Let's scroll all the way to the bottom and just look at the outputs we'll generate.
Do you want to choose to check the metro file?
Yeah, sure. Yeah, so maybe at the same time you could open up this folder, GSWP3.
See another screen.
So in this GSWP3-W5E5 folder, we have many different climate variables, radiation, precipitation, temperature. Let's scroll down maybe to the precipitation one. It's hard to put everything on the small screen.
Yeah, I'm trying to manage.
So for precipitation,
yeah.
Go ahead, yeah.
That's a PR one, right?
Yeah. So PR here stands for precipitation, and we see there's a file for 1901 to maybe drag it a little bit over. Yeah, perfect. Till 1910, another file from 1911 to 1920. So what we have in here is daily data, but each decade is held in a separate file. We see in line 201 of the settings file, where it's precipitation maps equals PathMeteo / and then we see the name GSWP3-W5E5 _ obsclim _ PR, and then we see a star sign. The star sign says to the program, just look for files in this folder that start with GSWP3-W5E5 _ obsclim _ PR, and then fill in the rest with so first look for a file that starts with that, and then we see that there will be many files that start with that, and then choose the one appropriate for the timing of our simulation. So if we were running from 1901 to 1920, it would first take the file 1901 to 1910, and then go to the file 1911, 1920 when it gets to those days of the run. Right now I think we're running from 2015 for 10 days, so it only is going to use this last file, 2011 to 2019.
This one.
Great. Okay, I think we have everything now. We can just run the Beamer basin.
You wanted to check the output you just said.
Thank you, yeah. It's always better doing this with you.
So now we only have the discharge as time series and discharge as map.
Whenever the number sign is there or the pound sign, it means it's just a comment, and the program will not read these lines of the settings file. So they are not activated. So yeah, just as you said, the only two lines that are activated is this daily map for discharge and this time series map for discharge. Cool.
So now I save the file and run it. Go back to the tutorial, exercise 4, and we edit the Beamer basin. Just to open it to see what is inside, yeah. Just one line command to run the model.
So to run the model, it's Python, then we're calling the model itself, CWatM, and then we call the settings file.
The configuration file.
And then -L, which means loud, which it shows us some outputs throughout the course of the model running.
And we just run it.
So we're running this at 30 arcmin, and the Beamer basin is relatively small for such a resolution. So it'll butcher the outline of the Beamer basin, but at least it'll run faster for this example.
So
now let's go look at the outputs. Output folder. Discharge _ daily. Yeah, let's look at the map. So Ting's going to open this map with PanApply, which is a program from NASA to visualize netcdf files. Also requires Java. We can go through downloading that in another video, or go ahead and use PanApply or any other program that allows one to visualize netcdf files.
Sorry, I think my PanApply wants to react to me.
Maybe it's open already. It won't open something if it's already open. It's a bit clunky like that.
But I don't see it open.
It's a little penguin.
I just close it to open it again.
Yeah. Yeah.
And
then Ting double clicks on the name of the variable discharge. And now we're running for a small basin at low resolutions. So Ting is zooming in to India, holding control and then clicking. Yeah, thanks. Here we see the low resolution shape of the Beamer basin with the higher discharge in red, the lower discharge in blue, I'd assume, with this color palette.
So output is either this one or this one. Maybe just also good to clarify, this is only for testing purpose. When you really run a hydrological model, you would not run 30
arc
minutes for a basin like this.
Yeah, 30 arc minute now we use mostly only for the global runs.
Large river basins.
Or large river
basins.
But even still, we seem to be all moving to 5 arc minutes even for global runs, so 10 kilometer. But here we're looking at 50 kilometer by 50 kilometer about resolution. Again, great thing for testing purposes. So this is the shape. We saw that it ran. Now we're just going to, the goal of this is to run for a basin of our own choice.
Should I also look at the time series file?
Yeah, sure.
Maybe you can reflect again on the on the spin up. The time step for spin up.
Right, so we see outputs here for 3, 4, 5, 6, 7, 8, 9, 10. So steps 1 and 2 didn't produce output because we told the spin up the start of producing outputs for the 3rd day of the run. So when we look at when we had the discharge underscore daily as a map, we were looking at every single point within the basin. But here we're just looking at a single point in the basin, discharge for a single point in the basin. This point is designated in the settings file under gauges.
Yeah, maybe I could show.
Yeah, great. So yeah, this line 115 gives the location of longitude, latitude of the point we're interested in having the discharge data when it was just for a single point, so it's the time series. So that time series was showing us the discharge from this point, longitude, latitude, which was, in this case, the outlet of the basin.
Cool.
Ooh.
So anything else we could... maybe this mask map is also interesting.
Yeah, well,
that's what we get to next,
right?
Cool, so we get to the next steps.
Right, so we have this file upstream underscore area underscore kilometers squared. We want to open this up in QGIS, ArcMap, or in this case, ArcGIS Pro.
I only opened the ArcGIS Pro software because it takes a bit of time to load.
And then you're dragging this file in.
Yes.
Yeah, okay.
I'm going to move this to this screen.
Zoom to layer.
So this is a global.
So what this map is showing us is upstream area, or a flow accumulation map. So for each cell at 30 arc minute, the cells with the higher values have more cells upstream of it. So points at the end of large rivers have higher values because more points are upstream of it. More points, if water were going to go from one cell to the next cell to the next cell, points at the end of large river basins would have more upstream cells. So I guess right here you've zoomed into the Amazon.
Amazon, yeah. You say also the tributaries contributing to the main channel of Amazon. So what should...
Maybe we can invert the color scheme, just so that black is the highest value point. And then put a base map underneath, so we can know where we are.
So we put OpenStreetMap.
That's good. And I guess it's still loading, but while it loads, maybe we can make the upstream area map somewhat transparent so we can see underneath. Click on it.
The raster layer, we increase the transparency. We can test how much.
What river basin have you chosen?
An interesting one.
Is there a
Well,
non-interesting one?
well, everyone is interesting in their own ways, but this one is interesting for us because I don't think we ever had an example with this one. It's this one right here. It's called the hydrological, but I don't speak the local language, so I don't know if it's correct. So basically, to the north of Amazon, this part should be
No.
already the Amazon, and
Okay.
this is the river basin that drains to the Atlantic Ocean. And most part of it is Colombia and Venetia.
Venezuela.
Yes, thanks for correcting. So it's actually corresponding to this. This would be the northern, like towards the ocean.
Cool. So now the role is to find the location of the outlet of the basin. So basically the point there that has the largest value. So the darkest point before reaching the sea. So
I suppose it's this one?
yeah, just exactly. Yeah.
So this one have after value about 960,000. And we can look at the upstream one, which is a bit slightly smaller. So this would be the largest, right?
Great. Yeah. So now we just find the longitude and latitude of that point.
And this comes up in the lower, how should I say it's here?
Yeah, I guess so.
Should we record it?
Yeah, if you zoom in as much as you can, then we'll...
Is this enough?
And hover, yeah, okay. Zoom in even more, just to make sure we get it exactly.
Maybe lower the transparency to see like where is the boundary of the map, of the grid. Yeah. So basically, it should be here, right?
Yeah. Okay, so let's say 60.7897 west. 5.
How many
1.
digits do you think we need?
Let's take 3. At 30 arc minute, I think we'll be safe because we're not on the edge of it.
So then we are done and we go back to the settings file, right?
Yes. Okay, so we want to do longitude and latitude. Yeah, maybe just copy the Bima basin settings file and create a new settings file. Called it, we can call it the name of the basin.
Is that how it's? I think it is how it's written.
Cool. Great choice, Ting.
Let's see what comes up.
Right, let's see what comes up.
So what do we do here?
We're going to go to mask map. Okay, instead of this, we want to do longitude, latitude. So the longitude, let's do 60.7897. And latitude, 8.651.
Oh, did I do something? 6 points.
I think you got it.
Okay.
That's what I have. And copy
so there's
this.
one more digit for. Does it matter?
I guess not. You can take away the 7. We'll see what happens. Can you also copy this location into gauges? The gauges has to be within the simulation area, within the mask map area, or it'll complain.
Maybe just to explain the difference between the mask map, if you put a point, That's the point where you consider as the outlet of the entire river basin. But the gauge is where you where the model reports outputs, right? So there can be more gauges.
Yeah, totally. So gauges could have many different locations separated with spaces, while MassMap just has one spot that then builds the upstream basin from it.
Yes.
MassMap, one can also put a shapefile or, sorry, a raster map. But if one knows the outlet of the basin, one can simply put in the location of that outlet. We'll do an example with for example, the Rhine basin, when we were running it, was using a shape or a raster map. Well, in this case, we just use the outlet of the basin we're interested in.
Super.
Okay, I think
So
we got
that's
everything.
it. We save it.
Yes. Save it, run it.
And we make a new file here. Oh, it's Orinoco.
Orinoco.
I put the A, but it should be an O. And then we edit the
Right.
the settings file. And then, should I run?
Yes.
It also went to the other. Error. MassMap point does not have a value in the river network. Why the values get higher when I'm going to west? Ah, yeah, because it's in the west. Ah, it should be minus because it's in the west.
It should be minus because it's in the west.
Yes.
Yes.
Because east is positive.
Yes.
Is it?
Yes. 180s starting within Europe going all the way around. This should be negative. Try it.
So -6. If we can go back to this one, right? 60.75, I think.
Yeah, minus 0.689 I have.
Sim 89.
And yeah. Great problem solving, Ting.
That's why we are doing this together.
Yeah, we don't have. You're right. We don't run too many things in South America yet. Perfect.
The size matches. So
The size
this is
matches.
close to 1 million square kilometer, and that's a sign that the mask map works, right?
Yes, perfect, Ting.
Actually, did I mention the size of this catchment? In case I didn't, it's actually in this. It's written. It's close to 1 million square kilometer.
And again, since we're doing this at 50-kilometer resolution, we are still, although it's so large, butchering the shape of the basin. So as long as the size is relatively represented or relatively close, we can guess we have the right basin. But we can check the outputs and see what it looks like.
Mm-hmm. You mean the output?
Yeah.
Of the map output.
Again, this output shows for every cell the meter cube per second average for the day that it's representing. Rating.
That's worked.
This is the first day of the simulation, the discharge.
I wonder what is going on here, though.
It's just the first day of a run without a warm-up. So I wouldn't take it so seriously. It just sort of shows us that we're running the right basin and the model's producing output. But to actually take results that we can take seriously, we do at least a longer run with some warm-up and some preparation.
Super.
Super. Well, always a pleasure, Ting.
Great, great.
Everyone else, schönes Wochenende, schönen Morgen, schönen Tag, schönen Abend, gute Nacht.
Yes. Bye.